Hello students, welcome to the Master School Foundation program. Today we are going to deal the very important topic, that is lenses. If you are going to take that different types of lens and their crafting, you have to identify. Already we have studied about that the properties of light when it is allowed to pass through the plane surface and the curved surface. We have studied that reflection of light and the refraction of light through the plane and curved surface. Alright, now it is time to have a look into that matter of refraction of the light through the lenses. Yes, alright. Okay, let's have a look into that matter. Yes, everyone has to see types of lens, general terms related to the lenses. Alright. This is the concept that we have to discuss. Okay, if you are going to take that spherical mirror, you have the different methods to study about that properties of the spherical mirrors, and when it is allowed to pass the light, so you have been studied about that reflection and refraction. Spherical surface, it's very clear. As compared to that mirror and lens, we would like to know about that difference. What is the difference? What is the mirror? If you are going to get that fully reflecting surface, yes. So as compared to all the metals, silver metal is going to be having that best reflector, so that the silver coating has been preferred to get that reflection. Alright, it's very clear. So that is going to be that mirror, it's very clear. If you have taken that curved surface, which is going to be compared with the spherical, that is going to be imaginary sphere which has been drawn to study the properties of the image formed by that refracted light rays. We need to take the geometric relations which are imagined with the help of sphere. It's very clear. That's what we are going to get, that spherical refracting surface. All we are going to talk about that. Okay, let's have a look into that matter. Lens, you would like to go for this one. Alright, if you are going to get this one, if you are going to identify that a well crafted lens, it is going to be the plane surface, it's going to be the curved surface. At the edges, at the center, you have to confirm. At the center, if you are going to get that the surface is going to be, you have to identify that the surface which is going to be the thinner and thicker, which is going to be bulged surface at the center. At the end, you have to confirm it's going to be lens. It's very clear. So if you want to get the different cases, light is reflected from the top of the surface and it is entered to the transparent surface, that is lens. After that, there exists a refraction. So if you have been studied that interference and reflection, refraction, diffraction, all these are going to be exhibited by the transparent materials which are made up of with the different types of the glasses. Yeah, you can take that. That is very clear. You would like to go for that. What is the lens? Just you have to confirm. It's a transparent medium. It is very clear. You would like to know about that lens is a transparent medium which is bounded by the two surfaces, of which either of the two surfaces are going to be spherical. Just you have to take that. So one surface is spherical, one is plane, you have to get that. Two are the spherical. One is spherical. That's what you can take that plano concave, plano convex. That's what you have to get different types of the lenses. The purpose of all these well crafted lens is going to be having the best view, and in order to eliminate the defects in the eye vision, and we are going to have that these lenses are installed in telescope and microscope to have the view, to have the better view. Yes, in order to view the very long objects which are situated at very long distances. This is very clear. Okay, the function of different lenses is going to be the different. It's very easy for you to have the look, right? Yes, thin lens, a piece of transparent optical material bounded by the two refracting surface, usually spherical. One surface is being spherical, another one is going to be plane. Yes, it's very clear. So, you are going to get this one. Yes, you have to get this one. It's very clear. This is going to be, yeah, we have to imagine that is a part of the sphere, just you have to take that. Yes, we are going to get this one. Yes, now we would like to go for that thin lens and thick lens. This is going to be, basically we are going to get that one or both the surfaces are spherical. If both the surfaces are spherical, you have to get this. You can name it as that convex lens or concave lens, just you have to imagine. But if you are going to introduce that another part is going to be the plane surface, that is known as plano convex or plano concave, or you have to identify this one, very clear. Yes, thin lens. We have to get that thin lens and thick lens, it's very clear. Yeah, if you are going to wear the eyeglasses or contact lenses while reading, you are viewing these boards through the pair of these lenses. Yes, if you are going to be, imagine that the distance between the two curved surfaces are going to be very small, it's very clear. So, they are going to be compared with the part of the sphere. It's very easy to have that properties of that lenses. All right. That's what we can neglect the distance. It's very clear. Yeah, we can neglect the distance between them. It's very easy for you. We have to get the thickness of the lens. We call it as thin lens. It is very clear. Yes, you have to get that. While you are going to consider that distance between the two spherical surface, the distance is going to be very small. The distance is going to be very small value. That's what we are going to get the thin lens. Thick lens and thin lens are compared by the distance between the two spherical surfaces. Yes, types of the lenses, you have to take that. So, generally if you are going to take that, their function is going to be the different. Yeah, they are going to be crafted, yeah, based on the distance between the two spherical surfaces is going to be large and small. Just you have to take that. If they are going to consider the distance is going to be the large, it's going to be that convex lens. It's very clear. Otherwise, you can take that distance is very small. It's going to be neglected. That is going to be the concave lens. It's very clear. If you are going to get that convex lens, it's going, what is the behavior of light? It's very clear. If the lenses, you have to take that converging lens, or yes, while you are going to talk about that, yeah, converging and diverging, just you have to get that. converging. Yes, it's very clear. They are about to meet at one point. It's okay, it's very clear. You have to get that diverging. So, yes, after the refraction, just you have to confirm their function is going to be. It's very clear. After they will meet, just they are going to be diverging. It's very clear. Yes, in case of that convex lens, if you are allowing the light rays are going to pass through them, just there exists a converging. The light rays are all about to meet at one point to form the image, it's very clear. Simply if you are going to talk about that converging and diverging, so if you want to concentrate all the incident light at one point, they are allowed to pass through that a particular lens. Sometimes after the refraction they will meet at one point. After the refraction they are going to diverge. They may meet at somewhere else, we don't know, right? That's what they are going to be, the diverging lines. It's very clear. If you are identifying that converging and diverging, easily you will find out that in electric and magnetic fields also, electric lines of force, they are going to be diverging. If you are going to take that magnetic lines of force, they never leave the field. They are going to be the circulating within the region. They are going to be closely concentric circles. So, they are the converging lines. It's very clear. Okay, if we have been studied previously regarding to that concave mirror, which is going to, yeah, it is time to know about that. It's very clear. If you are going to take this one, the incident light rays, they are going to meet at one point. They will meet at one point after the reflection. All right. This is about that mirror, yeah, which is going to form that real image. All right. Okay. That is for concave mirror. All right. If we are going to talk about that fully silver coated surface at the end of that glass, just you have to confirm, being a 100% reflecting surface, it's going to be all incidentally reflected, and they are about to meet at one point to define that position of image. All right, it's very clear, but the nature of the convex lens is going to be the different. You have to find out that. That's very clear. We would like to get that, the nature of the convex lens and the concave mirror. They are going to be, their function is going to be different. Yes, it is very clear. They are going to, this is going to be the reflected light rays. In the same fashion, if we are going to get this, all the incident light rays are going to, yes, they are about to meet at one point. Yes, you have to find out this one. This is very clear. They are about to meet at this point. This is going to be that case. This is the convex, this is convex lens. It was happened, what you have been observed in case of that concave mirror, it is going to be reflected after the refraction. The light rays are about to meet at one point. It is very clear. Okay, all right. So you are going to get this one. If you are taking that, we are going to derive it like that. Yeah, this is about convex mirror. Just you have to take that. It's going to be identified in different cases. So previously we are going to have the information regarding to that, the interaction of the light rays, how they are going to be meet at one point after the reflection, how they are going to meet after the reflection, how they are behaving after the reflection and after the refraction. You have to confirm that. It's very clear, the reflected light rays and the refracted light rays having the capability to form the image. It's very clear. That's what sometimes you need to find out that real and virtual image, which is going to be real, which is going to be the virtual. You have to confirm based on the behavior of this reflected or refracted light rays. Okay, it's very clear. Would like to go for this one. Yes, if you have seen this one, it's going to be what the distance between the two spherical surfaces. This distance is going to be large, which is not at all going to neglected, right? Very clear. This is also one kind of lens. Just you have to take that. Yes, what we have. Yes, you can take that. Biconvex lens and plano convex lens, concave convex. Just you have to take that. It's going to be. Yes, their function is going to have the different result. Okay, right. If you are going to get this one, once we would like to discuss about that. It's very clear. If you are going to take this one, if you have been placed that, this is going to be plano convex lens. Let's assume this is the plano convex lens. You have been placed that, yeah, you have been placed that here due to presence of air. Yeah, this is air. Just you have to. When light rays are incidented, yes, you have to see. The light rays are incidented. Let's assume. Yes, they are going to be refracted and some light rays, yeah, due to the presence of the different density and just you have to take that. Yeah. So you can take that. This is going to be the first one. This is going to be the second one. These two rays are going to be interfere with each other. Yes, you have to take this one. Just you have to take this one. Yeah, they are going to interfere. There exists a interference. Yes, the light rays are which are going to be reflected, which are going to be refracted due to the presence of the plano convex lens. Some light rays are going to be, yeah, from air to glass they are going to be refracted, all right. After the refraction, some light rays are allowed to get that refraction, they are going to be reflected back, and these light rays may superimpose with each other, all right, to get that interference. So you know very well about that interference experiment, how it is going to get that maximum values, all right. So these type of the lenses are very useful in the experimental analysis, all right. And there exists a I maximum, intensity is going to be maximum, I is going to be minimum sometimes. Just you have to take this. consideration. All right. Now, you would like to talk about that different lenses and their functionality. Later we will discuss about that. Yes, convex or converging lens, convex lens, just you have to take that. It is very clear if you are going to get that the distance between the two surfaces which are going to be crafted, the distance between the curved surface at the center, it's going to be minimum, it's going to be small, it's going to be larger, it's very clear. Lens which is thicker at the center, all right, it's very clear, and thinner at its end is called the convex lens, all right. Convex lens are three types as shown below, it's very clear: biconvex lens, plano-convex and convex meniscus. Just you have to take that, we have to confirm. Yes, it is very clear, we would like to, convex lens is also known as converging lens because, yes, it converges, it is very important, all of you please have a look. It converges a parallel beam of light rays passing through it, converges the parallel beam of light rays passing through it. Converge means they are all meet at one point. Let us take that on the principal axis, they are about to meet at one point to define the focus. To have that focus, it is very clear. In order to identify the focus, just you have to take that where the all the refracted light rays meets at one point and they are all about to meet at one point. That is what you can define that principal focus, it is very clear, all right. So, converges the parallel beam of light, just we are going to take that parallel beam of light rays, very clear, yeah, the parallel beam of light rays. This is the parallel beam of light rays, they are going to meet at one point, that is you have to take that, very clear, they are about to meet. Yes, you have to confirm this one. Yeah, it is going to be converge. They are going to be converge at this point. Just you have to take that. All right, it is very simple. You can define that convergence of the light rays. They are going to be allowed to fall on a lens. So, the parallel beam of light rays has been incidented. Yes, after the refraction they are all about to meet at one point. It was happened in case of convex lens. So, you have been obtained this point, yeah, on the principal axis, just you have to take that, yes, which is going to be undeviated, but it has been incidented normally. Other than that you can take that, it is very clear. Yes, you can go for that next. Yes, you have to confirm this is going to be the concave lens, right. Just you have to take that the middle portion, what that middle portion is going to be getting that the plano concave, right, concave. Yes, you are going to get this biconcave, this is going to be the plano concave, one is the plane and another one is going to be in the concave. So, you want to get that the distance, it is going to be between the two spherical surfaces, it is going to be minimum. Just you have to see, this is very clear. Based on the distance you can define that at the center it is going to be having the minimum distance, at the end point if you are going to have that maximum distance. So, you can define that the convex lens and the concave lens, this is going to be the concave lens, it is very clear, right. Okay. Yes, at different situations if we are going to execute the functions, so you wants to get that magnify, you wants to concentrate all the incident light rays at one point, that is going to be in your daily life, all these are having the different practical applications, right. Let's go for this one. Concave diverging lens is a lens what we have discussed, that a lens which is going to thinner at the center and thicker at the end is called a concave lens. It's very clear. Concave lenses are the three types. It's very clear. Just you have to see. That is going to be double concave, plano concave, concave meniscus. It's very clear. Because of their shape, because of their crafting, yeah, we can name it as going to be double concave, plano concave, and concave meniscus. It's very clear. Yes, concave lens is known as diverging lens. It's very clear because it diverges the parallel beam of light rays passing through it. They are going to diverge. When they are going to allow to pass through the concave lens, they will diverge. It's very clear, right? Now, if you are going to talk about the divergence, just you have to identify this one. It's very clear. Just you have to see, whenever the light rays are going to be incidented, they are going to be diverged. Just you have to see, this is very clear. You have to see the divergence of the lens. So, they will meet it somewhere else, maybe infinity we have to assume, but they are in a actual practice they are not at all meet it at one point, so that they are going to be known as diverging lens, which diverges the incident light. It's very clear. If you are going to talk about that divergence of the light rays, you can take that magnetic flux and electric flux. While you are taking that one point, you have been assumed a point charge has been placed around it, its influence has been spreaded. So, the magnetic flux is originated from that point source. So, their influence is going to be presented up to the somewhere else. Yes, if you are identifying that, the electric lines of force are known as the diverging lines, but the magnetic lines of force are going to be the converging. It's very clear, they are going to get that. That's what, if you have been placed the one point charge here, its influence can be spreaded up to that infinity. Just we have to assume that is very, very important. So, they are going to be diverging. But, okay, it's very clear, right? Double concave lens is simply called as concave lens. It's very clear. It's going to be that, yeah, complete part. The lens is going to be the complete part of the two curved surfaces are going to be joined together. They are going to be crafted to attach to get their, to define their maximum distance at center and minimum distance at the end. It's going to be very clear. It is going to be in the reverse order, you can confirm. All right, that is going to be concave lens based on the distance. All right. Some definitions related to the lenses, it's very clear. So, if a optical center, you have been incidented the light rays without, you have been incidented the light rays which is going to be passed through the center, what happened, it is going to be undeviated. Yes, right. It depends on the incidence. You have been incidents in a one direction. Just you have to take that. It's very clear, right? Yes. The center point of a lens is going to be the optical center. It is represented by O. The optical center is a point of the lens, yeah, directed to which the incident rays refract without. Just it is very clear what we have discussed, that the incident light rays refract without any deviation. That is the important point, just we have to discuss. This is going to be that center, you have to take this one. Yes, you have to take this one, it's very clear. They are the light rays are incidented, it's very clear. But have you seen that generally if we are going to talk about that refraction, so yeah, if you are going to talk about that, when light is allowed to pass through the rarer to denser medium, what happened, or denser to rarer medium, there exists a bending of the light rays towards the normal or away from the normal. It's very clear, when the light rays are allowed from rarer to denser, they are going to bend towards the normal, rarer to denser. If you have identified that denser to rarer medium, they are moving away from the normal, it's very clear. So simply when light is allowed to pass through two different media of the different density, it's very clear. So there exists a refraction. Here what we have seen, the optical center is going to be defined. It is a point at which that the light rays are going to be incidented, and without getting that, if they are going to be allowing to incident at the center, there exists a no refraction. It is going to be undeviated light ray which is going to be passed without any deviation. Okay, it's very clear. So that we can easily identify this one, right? It's going to be having the representation O. It's very clear. Just have the look. Yes, it's very clear. You have to identify this one. Yes, everyone has to find this one. O be the optical center. It's very clear. We would like to go for this one. Other than this, what happened? If you have been incidented in different direction, they are going to be refracted. All right, it's very clear. General terms related to lenses, just we have to see. Center of curvature, it's very clear. We would like to go for this one. Just you have to see, it's going to be identified. Yes, we are going to get this one. C1, just we have to get that center of curvature. That is going to be, generally we are going to have that lens. Yeah, this is going to be the common area, common part. Two centers of the curvature, it's going to be C1 and C2. We will identify that. Yes, if you are going to get this one, there is an imaginary part which has been drawn, which has been fulfilled to get the geometric relations. That's what you are going to get, that C1 be the center of that imaginary sphere, C2 be the center. It's going to be that the completed portion, the imaginary space. It's going to be spherical. You have to get that. It's very clear. Right, that's what you are going to be, the imaginary spheres of the centers of two imaginary spheres of which the lens is a part. You are going to get that two ends of the lens. From that ends you are going to get that imaginary sphere, and you have been drawn it, and you have been obtained that center. If you are going to take that lens which is having the two curved surfaces, yeah, for two curved surfaces, you are all going to get that center of curvature C1, and center of curvature is going to be on either side of these two curved surfaces. You will get that center of curvature C1 and C2. It's very clear. Now we can easily identify that. Right. Yes. Radii of curvature. You have to get that radii of curvature. Yes, it is also in the similar fashion you can understood. Yeah. Yes. The radii of the two imaginary spheres, which of them lens is a part, is called the radii of curvature. It's very easy for you to have that the imaginary sphere has been completed on either side of the curved surfaces. So you will get that radii of, generally if you are going to get that sphere, you have that radius, it's easy to identify that. So radii, we are going to get that radii of curvature on either side, just you have to imagine, alright. If you are going to identify that lens has two radii of curvature, very clear, these may or may not be equal, generally they are going to be identified, they are going to be equal or may not be equal, it's very clear. It's very easy for you. Converging thin lens, you have to find out this one. This is going to be that, yeah, you have to be imagined. It's very clear. It's very clear. Again, you have taken this one. Imagine this way. Yes, all right, you have been imagined this one, and it's going to be, see, just you have to get that C1 is the center, C2 is the center. It's very clear, you would like to go for this one. Based on that C1 and C2, you will have the geometric relation with respect to the position of image. With respect to the position of object, you will get that image distance. It's very clear, right? Just you have to confirm, this is very clear. Yes, you have to take that. Either just you have to see, this is R1 is going to be, yeah, you have to take that R1 and R2, just you have to take that. It's going to be R2, this is going to be R1. R1 greater than or equal to 0, this is going to be the R2, all right. Yes, you have to take this one. Yeah, if you are going to get that sign convention, this is going to be the negative, this is going to be the positive. That's what you have to get, that R2 is going to be less than or equal to 0. It's very clear, you will easily identify this one. Yes, you have to take that, this is going to be, imagine, just you have to take that. R1 and R2 are the known as radii of curvatures. It's very easy for you to represent. Yes, you have to get this one. The radii of two imaginary spheres of which the lens is a part is called radius of curvature. Lens has two radius of curvature. Yes, it's very clear. That has been identified in case of the concave. It's very clear. Let's have a look. Just you have to take this one. It's very clear. We would like to go for this one. Yes, in this case also you have to confirm. It's very clear. You would like to get this one. But you are going to get this one from this endpoint. So you will identify that R2 is going to be greater than or equal to 0. R1 is going to be less than or equal to 0. It's very clear. Yes, you have to take that. This is the case we can confirm. All right. Now, if you are going to get that diverging thin lens, in case of the diverging thin lens, you can imagine that the imagined sphere has been drawn, and here also the imagined sphere has been identified. It's very clear. All right. Now you can get that center, and you will get that R1 and R2, radii of curvature. It's very clear. Yes, you will get the principal axis. While you are talking about that principal axis, which is going, the imaginary line, principal axis is going to be having that high importance in measurement of the object and image distances. So where the refracted light ray cuts the principal axis, that is going to be that image distance. All right. If you are going to get that real image and virtual image, you have to get the position, whether it is correctly situated. The refracted, the incident light rays are further proceeded and they are going to refract and they will meet at somewhere else. They'll meet at some point that is going to be on principal axis. You have to get this one. All right, it's very clear. It's very clear. Which is passing through. This is the principal axis xy. It's very clear. Okay, students, in the coming classes also we would like to discuss about that more about lenses. Have a nice day. Thank you very much.